Hello, so today we're talking about a support ticketing use case. We will focus on IT industry, but in general, this use case is usable for any kind of industry. The typical goals of customer support are improving customer satisfaction, so ensuring that SLA on ticket response and resolution time are met, and ensuring that the resolution is effective, so the customer is happy and will not reject the solution of the ticket. Second goal is improving efficiency and productivity. So minimize changes to the tickets in order to reduce time spent by support agents, which will also reduce the cost of the support agents. We will jump immediately into the tool to see how IBM Process Mining can help with this use case. So this is a process model visualized from the Gyro application, which is a very common application used for IT support. At the first glance, we can immediately see the most frequent activities. So we can see that the tickets are open, assigned, put in progress, resolved, waiting for validation, and then closed. And still at the first glance, we can take a look, for example, at duration in order to see immediately that we have bottlenecks. So we have high duration activities and transitions when the support agents have to wait for the user or when there is a change in the person assigned. You can see it because the arrows are thicker, If we go immediately into the analysis, we can take a look at the executive business dashboard to evaluate overall process performance and especially understand if there is room for improvement in terms of SLA adherence and where are possibly the issues. If we focus immediately on resolution time for high and medium priority tickets, we will see that there is for sure room for improvement because on average, the SLA are never met. If we focus, for example, on request type tickets for high priority, there is an average delay of almost 3 days. On the first response time side, the medium priority tickets are actually on average always meeting the SLAs. So here we are good. But still, on the request types, we can see that for high priority tickets, there is almost a 4 days delay. So for sure, we need to understand how to improve the timeliness of this process. And we may start actually from this table where we see activity impact on lead time. So we can see that we have change in request type that is impacting almost 40% of the lead time of the processes where this activity occur, as well as change in person assigned, which is impacting 35% of the lead time of the processes where this activity occur. So for sure, we can identify here the room for improvement, the improvement opportunity in order to improve our SLA adherence, so the process timeliness actually. If we analyze it from a cost perspective instead, we may take a look at the fact that the human cost due to changes, so the FTE allocation of the support agents to change something in the ticket, is costing almost 10% of the total cost. And still, the higher FTE cost are allocated on changing request type and change in person assigned, the same two activities that are impacting also the process timeliness. From a rework perspective, you can also see that reopening the ticket, changing the ticket and putting it back in process is creating cost of reworks of over 5,000 euros. This is already enough for us to understand that we may want to do something for changing request type and changing person assigned activities. And the solution that we proposed here was actually to automate using AI, natural language processing, and of course, RPA, in order to automatically assign the ticket and automatically classify the ticket type. Now, the cool thing about IBM Process Mining is that once you have a what-if scenario in mind, especially regarding automation, you can use our simulation tool to precisely forecast what would be the benefit in terms of time and cost of the process. And this is exactly what we're looking for. To do that, we need to start from the as-is process to understand if there are behaviors that we want to eliminate and behaviors that we want to emphasize, bring in our optimized to be. In this case, I want to focus on these three activities: changing request type, actually, changing person assigned, and first assigned. What I'm noticing is that changing request type has already a 42% automation ratio. So this is a behavior that I want to emphasize in my to-be. I want to increase that automation ratio. On the assignment side, we have never an automatic assignment. So this activity is not automatic. And in fact, sometimes there are changes in the person assigned. So now I'm applying a filter that is, as I was saying, emphasizing the behavior that I want to bring in my optimized to be and removing the behaviors that I don't want to have. Let's see. So we have auto request type or no request type. So we would like to have our request type association classification performed automatically. And I don't want to have change in person assigned in any process. So ideally, this change should never occur because we want to automate first assigned in order to avoid any change. And of course, I put activity is closed in order to consider only completed processes. I can now create a simulation scenario. And the cool thing about our simulation is that all the inputs, all the configurations are automatically retrieved from the as-is. So everything is based on the real process data, which means all the evaluations will be very precise. And this is why we call it digital twin of the process, you know? I just need to look for the activity first assigned and introduce an automation ratio here. I can put, for example, 80% with 2 robots and a working time of 1 minute, let's say. So we will have this robot that will automatically assign the right team and resources to the ticket, based, of course, on the content of the ticket and on the capabilities of the support agents. I don't have to change anything else. I can directly run the simulation. And this is the simulation result. So we can immediately see that if we implement the what-if scenario that we have in mind, we would be able to save almost 50% of the process lead time, going from 10 days to slightly more than 5 days. And this would hopefully help the support team to meet the SLA much more often. From a cost perspective, there is a huge improvement as well. If we take a look at the total cost, there is a 25K saving, which is around 30% of the total FTE cost. Very, very interesting. And so we are basically proving to our customer that this automation strategy would be effective from a time and cost perspective. Of course, the customer can then take this data, evaluate the cost of implementing the automation, and eventually start the automation project to improve the process performance. So till now, we have evaluated and designed a process automation, process reengineering scenario that aims to help the customer improving the overall process performance in terms of time and cost in the future. Of course, this kind of initiatives takes time to be implemented. And that's why IBM Process Mining also wants to offer a set of capabilities that can help the customer immediately reaching their KPIs. We call them operational excellence. And the goal of operational excellence is actually to monitor ongoing processes, in this case, running tickets, in order to speed up the execution. Let's see 2 examples. If we take a look at resolution SLA, the operational excellence dashboard is showing us all the tickets that are still not resolved. Imagine that today, of course, is October 31st of year 2022. We have 10 tickets that have still not been resolved. And they have been, pending on the last step, on average for 50 days. We can see that there is one high priority ticket and a sum of 9 medium priority tickets. Here we can check, is the resolution SLA already due? And we can see that this is true for all the tickets. We can see that these medium priority tickets are being due in terms of resolution SLA for a lot of time. And also the high priority ticket has been due for over 2 days. We can do the same kind of analysis for the first response SLA. So this is exactly the same dashboard. And even in this case, both are due in terms of service level agreement. Okay, how do we leverage these in order to actually help the customer meeting and improving the SLA adherence? We can do it using our monitor capability. In fact, here we have two monitors, one related to resolution, one related to first response, which will send a report with the tickets violating SLAs or at risk. This will help alert the support agents that they must give priority to these tickets, and hopefully this will speed up the resolution. This is a reactive approach, while the automation that we've seen before is of course a proactive approach to solve the problem at the root. These monitors are of course scheduled every day, and we are now running one to see what's happening. Imagine that I'm the agent, I'm using my common chat application, and I'm receiving this message. You have priority tickets violating resolution SLA or at risk. Check dashboard for additional detail. I can easily open the dashboard and see exactly that I have one high priority ticket that has violated the SLA that I must absolutely solve, and 9 medium tickets with the same problem. And that's how, on one side, we were able to identify a process reengineering, process automation solution that will improve the overall performance and prevent SLA issues to occur in the future, but also how we can immediately react to the issues using our tool in order to speed up the process execution from day one. Thank you for watching this demo, and let's stay tuned because we will have new use cases coming out soon.